Hey, hello guys, welcome, Vandanam, Namaskaram. I hope you're all doing good. Vibe here when Kannan is here. Today we are going to see Electrochemistry Part 4. Okay, so with this we are going to end this total chapter. We are going to discuss batteries, fuel cells, and at last but not the least, the corrosion. Maybe this video can be quite long, but this is a very worth it video, I think. Okay, so from this we are going to end this total electrochemistry section and we are going to jump into chemical kinetics. Okay, so what is the battery? Battery is a group of cells. Okay, battery has a group of cells where all these cells are being arranged in a series. Okay, in a series way. When these cells are being arranged in a series way, then that is known as a battery. Okay, see, this battery is there, right? This battery is actually of two different types. What are they? They are actually primary and then secondary batteries. Where the battery that we use in our day-to-day life are those where they convert chemical energy into electrical energy. That is what we are going to see. Okay, chemical energy will be converted into electrical energy. That can be observed, not only chemical energy, also thermal energy. That is something we will be observing in the fuel cells. Okay. Here, primary, secondary, total batteries are being segregated into primary, secondary, where primary batteries cannot be recharged, but secondary batteries can be recharged. And also one important thing, okay, so we will just discuss about primary, secondary, then we are going to go into what is the battery, what is the reaction, all these. Best example for a primary battery is a Leclanche cell. That is what we are going to see in the very beginning. Okay, so this is what, yeah, a Leclanche cell is a very good example. And also I can give mercury cell. These are those two cells that are given in NCERT. Okay. Mercury cell. This is something for a very good example for primary. Then coming to secondary, lead. Okay, lead. Yeah. So lead cell. Okay. Lead battery is a very good example. Then, yeah. So that's it. Based on batteries, these two are the basic segregations. Fuel cells is also there. Fuel cells is something that is also giving us energy, right? So I will also write fuel cells. Where this fuel cell is something thermal energy. Okay, thermal energy. See, okay, energy of combustion or combustion of fuels like hydrogen. See, the energy of combustion, also known as thermal energy, right? They both are similar, right? Okay, so or energy of combustion. Energy of combustion should be converted into electrical energy. Okay, electrical energy. This is what a fuel cell is. Okay, so this is what a fuel cell is. That's it. Okay, a battery, we have primary, secondary, then also this is something you have to note. Okay, now we are going to get into the topic. Okay, very in detail into the topic called batteries. I have a separate PDF. Wait, first we will save this. Hold on. Okay, so exit. 1 second, please. Just skip a few seconds in the video. So here we are having the primary battery. Okay, the primary. Oh gosh. Okay, so here we are having the primary battery. Here you can just observe it. So this particular part is there, right? This is known as positive terminal. This, okay, this total, yeah. So this is actually known as negative terminal. This primary battery, okay, first I'll just represent it. This is a primary battery. Primary. Oh gosh. Okay, primary battery. Yeah, this is positive and then this is negative terminal. Then this cover is there, right? This cover and then this cover. These two, it's not cover, the layer, okay? The layer is there, right? So this is actually this total layer here. The anode is going to be zinc. They have given that zinc casing. Okay, they have given this as zinc casing. Okay, they have given this as zinc casing, right? So this is what actually the anode is. This cover, sorry, not this cover. This yellowish part, this outer yellowish part. This is actually the anode. Sorry, the anode. Then coming to the cathode, which is carbon electrode. This center part, okay, this total is there, right? This is carbon electrode, which is the cathode. Then this is actually the anode. This is the anode. And also along with this, there is also magnesium dioxide, MgO2 is also there. Then graphite is also there. Okay, so carbon, MgO2 and graphite, magnesium dioxide, graphite and then carbon. These are the cathodes that are being used, but in anode we are having mainly the zinc. Then yeah, there is this separator. Then protective layer will be always there. Okay, in any battery there will be this protective layer, which is this bluish color. That is what the protective layer. Then magnesium dioxide, as I said, right? Magnesium dioxide will be also there, and also there is this space. Okay, there is this space between. Okay, space between. In order to neglect the space. Okay, so there is this space now. Space between anode and cathode. Okay, to fill this space. To fill the space between anode and cathode, there will be some substances that I use. So best example is the NH4Cl. Okay, NH4Cl is there, and also ZnCl2 is there. So this will be normally a paste. Okay, normally it will be in a paste-like thing only. Okay, normally this will be like a paste thing. Yeah, so that's it. This is what a battery is. First, what is cathode? That you have to remember. Cathode is actually having a series of elements. What are they? They are graphite, carbon, and even I forgot. Magnesium dioxide is there. Magnesium dioxide will be in powdered format. Okay, this will be in powdered form. And then the anode is in just the zinc. Then there will be the space. The space is being filled by this ZnCl2 and ammonium chloride. Okay. So here what you are going to do is we are going to see the reactions that are happening. Well, what are the reactions that are happening? I will just first represent what is anode. Anode has Zn2. Then cathode is there. So what is in cathode? Cathode, what we are having? We are having graphite. Then along with graphite, what we are having? We are having also magnesium, MgO2. Remember that magnesium can have, sorry, not manganese only can have valency from 1 to 7. Okay, then also carbon. Okay, then the carbon. Then okay, so anode, cathode is there. Then after that we are going to check out the reactions. Okay, so this is what anode, this is what cathode is. Then along with that we are going to see now the reactions. So in anode, what will be happening? Anode is a space of oxidation. where oxidation will be continuously happening in anode only. So that means what is it? Zn is there. So Zn will be converted into Zn2 plus 2 electrons will be released. Okay, so plus 2 electrons will be released. This is what will be happening in anode. Then in cathode, what will be happening? Cathode is a place of reduction. Okay, so cathode is a space of reduction, right? So MnO2 is there, and also ammonia is there, na? So NH4Cl is there, right? This NH4Cl, which is this ammonia, NH4Cl will be converted into NH4 plus Cl minus. Okay, NH4 plus Cl minus. So MnO2, NH4 plus. Okay, NH4 plus is there, and also 1 electron. Okay, 1 electron. So here 2 electrons are there, right? From that 1 electron would have come here. From that 1 electron would have come here. Not would have, it is what there. So what you will be getting? This one, okay, it can be there, right? You can note it out. So this is going to give us a complex, not a complex, yeah. So MnO into OH, into OH plus NH3. Okay, so plus NH3. Now where is the reduction? Okay, where is the reduction that has happened? If you check it out, here Mn is plus 4, here Mn is plus 4, but here Mn is plus 3. Okay, here Mn is plus 3, here it is plus 4. Yeah, so zinc, when you are adding this zinc and then this ammonia, NH3. Yeah, so that's it. Okay, so that's it. It is given in our book. That's enough. That's more than enough. These two are those reactions. Now, is there any net reaction that is like that? Okay, see, we are having this zinc 2 plus now. So when you are adding the zinc 2 plus with NH3 with this ammonia, this is ammonium. Okay, this is ammonium. NH4Cl is ammonium chloride. NH4Cl is ammonium chloride. When from this NH3 plus 1E minus, sorry, plus H plus, I think this is what the equation is. Well, I have to know the equation. Okay, anyways, from this only NH3 would have formed. NH3 would have formed. NH3 plus. Okay, when you are adding this NH3, this Zn2 plus. Zn2 plus. Then this will be giving you. Okay, this will be giving you a complex that's going to be Zn NH3. Yeah. NH3 into 4 2 plus. Okay, into 4 2 plus. Yeah, Zn NH3 into 4 2 plus. That's it. Okay. All confusions clear. Sorry, I didn't notice this NH3 when I was the one who has written it, but I didn't notice this. NH3, this NH3, and in this thing 2 plus will be combiningly forming this complex, which is ammonium. What is the name? Okay, they haven't given the name in the NCERT, so even I don't know. I didn't research about the name. So this one will be formed. Okay, Zn open bracket NH3 close bracket into 4. Oh, this is also known as close bracket only. This is known as close bracket. These two are known as open brackets, and 2 plus is there. Then one thing that you have to notice is the total cell potential. Cell potential is 1.5. Okay, a very common 1 mark question. Next is mercury. I'm very sorry for sudden change in the color. Next is mercury. Mercury zinc letter. It is just mercury cell, but also mercury zinc. Just mercury only will write. No need of any extra things. mercury cells, but this is known as mercury zinc cell. Okay, mercury zinc cells. Oh, I'm not branding anything, sorry. Okay, so coming here, this is what a mercury cell is, where there will be always cascades. Okay, cascades will be there also here. I think also in this cell also there is this cascade. Is there? No, there is not. Okay, see, first of all, cell can is there. The outer layer is what known as the cell can. This cell can will be always present in any cell. Okay, this will be present in any cell as a protective layer. There in primary we have seen about what is that? Leclanche cell, right? In that Leclanche cell we have already seen the protective layer. Here this is also the protective layer. Here there is cathode. Okay, this is what the cathode, and then coming to the anode, this is what the anode is. There will be the separator between these two. Cathode, anode, there will be a separator. Okay, now we are going to see what is the cathode in here, what is the anode in here. Before that, where is this mercury cell being used? First we will discuss about that. Mercury cells are commonly used as hearing aids, transistors, clocks and transistors, here hearing aid and watches. Okay, and then watches is where it is being very commonly used. So coming to the anode and then cathode, this is what the anode, right? So what is there in this anode? What is the composition of anode over here? It is just the amalgam. Amalgam is the anode. Then what about the cathode? Cathode is actually used, it is being formed by mercury oxide and also carbon. Even over there, cathode is what actually was a lot of substance. Over here also, cathode is what actually is made up of two different substances. There, cathode was made up of carbon, graphite, then also ammonium chloride. Here it is made up of what is this? Mercury oxide and carbon. There it is just zinc. Here it is amalgam. Okay, what is amalgam? Amalgam is where when you are having mercury plus any metal. Plus any metal. So the reaction. What is the reaction over here? Anode. First, what is anode? Anode and cathode. So what are the anodes and cathode? Just amalgam. Then what is the cathode? Cathode is magnesium dioxide plus carbon. Okay. Then what are we having here? We are having here reactions. Okay, reactions. Same like that only. We are going to see reactions. Reactions in different sites. Anode, yeah. What is this anode? Anode is made up of a few substances. Not the reaction is kind of complex over here comparatively with the last thing. Okay, last thing was just Zn gives rise to Zn2 plus and plus 2e, right? Here it is not like that. Here it is Zn into ZnHg would have formed. Okay, ZnHg would have formed. See, Zn plus HgO will give ZnHg plus O2, 2. Okay, so 2, so 2. Then this cannot be balanced. Okay, now it is balanced. Now it is balanced. Half. I think this is how it would have got formed. Other than that, no. Just the displacement reaction would have been the cause of formation of ZnHg. This is plus 2, this is minus 2. That's what going to be. Oxygen is not in the reactivity series. Okay, so plus 2OH minus gives rise to, okay, so plus 2OH minus gives rise to ZnO ZnO plus H2O plus 2 electrons. Okay, so ZnO plus H2O plus 2 electrons. This is what the reaction is. Then in cathode, at cathode, I know reactions are kind of complex. Not kind of, really they are complex only. HgO is there, then plus H2O is there, plus 2 electrons. Yes, in mercury cell also H2O is there. Okay, so plus 2 electrons gives rise to Hgi plus 2OH minus. Hgi plus 2OH minus. HgO plus H2O plus 2 electrons gives rise to Hgi. Yeah, here from where iodine came. Sorry. This is not little, that is liquid. Then this is ions. Oh god, I don't know why today I'm just talking a lot. Actually, I'm not in such a good mood of taking any videos. Today I'm very upset. Okay, anyways, coming back from my sad story, this is what the reaction is. Where for anode, Z10Hg plus 2 electrons, plus 2 OH minus gives rise to ZnO. Okay, so ZnO plus H2O, then also 2 electrons. So this water is what coming here. This water is what coming here. Other than that, water only formed in that mercury cell. This is the water that is over here. Okay, then the total net reaction, this and this can be cancelled. Net reaction OH minus, then any other thing that can be cancelled, water, electrons, all these can be cancelled out, right? Then what can be written as the total net reaction? The total net reaction is just zinc plus HgO, that gives rise to zinc oxide plus HgL, okay, plus HgL. This is solid. This is, okay, I don't know the states. Okay, this is also solid and this is also solid. What do you think? This is definitely solid. This one you all can comment in the comment section so that I can know this thing. You all can teach me that one thing. So this is what the net reaction is and its potential. Okay, there it was 1.5. Here E0 value. Okay, E0 cell or E cell. E0 cell is going to be 1.35 volts. Okay, it's going to be 1.35 volts. Remember, all these equations are kind of tough to be remembered. Only I will accept anode, but only this reaction. Okay, only this mercury reaction and this secondary battery. In the secondary battery also the total net reaction is very easy, but this is not that easy. In these two you have to remember. If you notice one thing, this reaction is what kind of tough than the cathode reaction. In this also, all you have to do is you have to remember that Z10Hg, this compound, okay, mercury zinc or zinc mercury, there is no chance of any other name. Zincoid mercury, no way. Mercurio, no, just zinc mercury. What other compound name is? We are going to say this as zinc mercury. The name of the compound is kept so that we can identify the compound. Here I have identified it as zinc mercury. If that is not the name, you can comment in the comment section. So zinc mercury, when you are adding OH minus, okay, OH minus to it, it gives you zinc oxide plus water. Zinc oxide plus water it gives. So this zinc oxide is there, right? So that will be just like that. This water will be taking place with HgO. Okay, HgO and water will be coming. Then these two electrons, see, these two will be just like that. They will be coming. These two will be coming over here. HgO plus these two, that will be giving you Hg plus OH minus. Okay, that will be giving you Hg plus OH minus. Also, this can be used in this reaction. Okay, this can be used in this reaction. So the compound over here, the product over here is taken over here. The product over here is taken over here. It's like a cycle, right? in the very beginning, a very minimum amount of OH minus will be there. Then after that will be used up. Then that will be just like a cycle. Okay, it will be cycle. Then after some time, it will be again charged. Sorry, this cannot be charged. Only the secondary batteries can be charged. I'm very sorry. Mercury and that Lagrange cells, these two are primary. Primaries can never be charged. Only secondary can be charged. Fuel cells are being continuously charged. Okay, they will be continuously charged. Okay. What is this? This is what the secondary battery is. Oh god, my handwriting is very poor. Just secondary. Okay. Just a secondary battery. Okay. Positive plate is there. This then the separator will be there. Then the negative plate is also there. Positive plate is what this plate. Okay, this is what the positive plate is. Positive plate. Then the second next to this is what the separator. Okay, this yellowish color is there, right? This yellowish color is what the separator. Then this blue color plate is there, right? That is what the negative plate. Okay, so these two, yeah, so that's it. So these are those three. Here even we are going to discuss two different types of secondary batteries. Okay, so the first thing is going to be the lead storage battery, and then the second one, which is very costly, that's actually nickel cadmium. These two are going to be discussed. Okay, the first one is secondary battery. Yeah. So secondary battery. In that secondary battery, what's it? What's that? It is nickel cadmium. No, we are going to discuss first lead storage battery. Here there is no such like what's anode, what's cathode, that at all we need not to see. Okay, like that we need not to see. Just we are going to see what is the process that is going to happen in anode. First in your examination paper also, first you have to write anode reaction, then when we write cathode reaction. That's what recommended because that is what given in book. There will be some sort of reason, right? Because in the total lesson in everywhere if you just notice, first anode will be there. Then after that only cathodic reaction will be there. I don't know why, what's the reason. Okay, so first, what is anode reaction? I have not by heart any reaction. Here only I have to by heart. It is actually PB, but I know the total reaction load because before examination I have just read it and I've got to the examination net reaction. Okay, so net reaction is there, that is Pb plus PbO2 plus H2SO4 gives rise to PbSO4 plus that also I forgot now, plus 2H2. Okay, plus 2H2. Okay, there I written correctly only. Okay, so Pb plus PbO2 plus H2SO4 gives rise to PbSO4 plus 2H2O. This is the total net reaction. In this, first you have to notice anode. What is in anode? Anode you are going to get. Okay, so Pb plus SO4 2 minus gives rise to. Okay, this one gives rise to PbSO4. Yeah, PbSO4 plus 2 minus. Okay, plus 2 minus. Next is PbO2 plus SO4 2 minus Yeah, SO4 2 minus plus 4H plus. Okay, 4H plus. See, H2SO4 when it is being decomposed or when it is being split, then it will be split as 2H plus plus SO4 2 minus. Okay, it will be split as SO4 2 minus. This is how it will be splitting. So that SO4 2 minus only you are seeing over here, because here H2SO4 is being split like that. So this is there, right? That has come from the 2H plus only. The 2H plus, when you're adding also another 2H plus, that one will be giving you 4H plus. Don't think of adding to the plus also another plus, because in 2H plus, okay, 2H plus means that there are two different H pluses. Okay, so 4H plus means that there are four different H pluses. Don't think of, okay, so 2H plus and also there is another 2H plus. So don't think of adding 4H2 plus. That is wrong. 4H2 plus at all will not come. So yeah, this is going to give you plus 2 electrons. Okay, plus 2 electrons is going to give you PbSO4 plus 2H2O. PbSO4 plus 2H2O. Now the thing is, there is no H2SO4 in the right hand side. Okay, there is no H2SO4 in the right hand side, in the reactant side, but there is SO4 2 minus, there is SO4 2 minus, and there is also 4H plus. So that you can write it as H2SO4. Okay, it just indirectly represents H2SO4. So this is what the reaction for lead storage battery is. And next is, we are also having, oh my gosh, this one we have completed now. I don't know why this is something. Okay, it's okay. I will write it in here even. Next is nickel cadmium. Before nickel cadmium, recharge. Okay, recharging. What will be happening in recharging? Recharging, the total reaction. Okay, on charging, the total reaction would have got reversed. Total reaction would have got reversed in sense PbSO4 will be producing. Okay, so PbSO4 will be producing Pb plus PbO2. Pb plus PbO2. PbSO4 plus H2SO4 plus 2H2O. Okay, plus 2H2O. This is what will be having. The total reaction would have got reversed. Next is nickel cadmium. What is this nickel cadmium? What is this nickel cadmium? See, only one reaction is there. Nickel. Okay, so cadmium plus nickel tri. Okay, I don't know the compound name, they haven't given. Cd plus, but my chemistry sir did say, I forgot. 2NiO3, okay, OH3 gives rise to, yeah, 2NiOH2 plus H2O. Plus H2O. So this is what the reaction is. All you have to notice is plus also CDO. All you have to notice is one thing. From here, OH has gone. Okay, one OH has gone. Not one OH. Yeah. So one OH has gone. So from there, what you can say, this one O is there, na? So this one O went to this oxygen, and that hydrogen combined with another OH. Okay, this hydrogen combined with another OH, and then it formed as H2O. Well, this total mechanism can be confusing. That is why they haven't given us this total mechanism itself. Nickel cadmium is a very costly cell, and the mechanism is very complex. That is why they haven't given us this nickel cadmium cells reaction. If in case it was very easy, now we would have studied that also. Okay, next is fuel cell. Well, for this, here even we can write. Okay, see, what is this fuel cell? Fuel cell is something that is used in Apollo space, not Apollo only. Yeah, Apollo space program. Apollo Please program. So what will be happening is, see, hydrogen will be passed, H2 will be passed, and also O2 will be passed. Okay, like this it will be passed. These two are porous. These two are porous carbon. Okay, porous carbon plates. Porous carbon plates. Then these two will be combining, and here there will be an electrolyte. Okay, mostly this electrolyte will be NaOH or also KOH, but mostly this will be NaOH. This will be NaOH only mostly. Okay, so this will be passed, and then there will be H2O that will be there. Okay, so this H2O is there, right? This H2O will be used by the astronauts. Okay, what is the spelling of ASTRONAUTS? Only I think the correct spelling is astronauts to drink water. Drinking of water. Okay, this is what it will be used by the astronauts to drink water. I know you might think, what is this fellow doesn't even know the spelling of in black. Oh gosh. No. Okay. Yeah. So cathode, anode, then the total reaction. That's it. Then also reverse reaction is not there here. Okay, just because always see continuously reactants will be added. O2 will be added and also H2 will be added continuously. For some reason this has got converted. Oh, all these has got converted. All the black markings has got converted into white markings. Next is anode. In anode what will be happening? In cathode what will be happening? In anode, so in anode 2H2, sorry, first always cathode is what written. Then when the anode is written, I said there oppositely, and in opposite way. First anode, then cathode is written. Sorry, first cathode and anode. First cathode is written. First cathode, then this anode, then this anode is written. So this O2 plus 2H2O gives rise to 4OH minus. Then this 2H2 plus 4OH minus this one. Okay, will be giving us 4H2O plus 4 electrons. Okay, plus 4 electrons. See, amongst here, half of the electron is went to cathode itself. Okay, half of electrons is went to cathode itself. Okay, so then the total net reaction is what is this total net reaction? Total net reaction is going to be what can be cancelled. These two can be cancelled, and amongst this it will be giving us just 2H2O. So O2, okay, O2 plus 2H2 gives rise to 2H2O plus 4 electrons. Here also plus 4E minus is there. Okay, so 4E electrons will be also cancelled. So this is what the total net reaction is. Very simple reaction. But one thing you have to notice here, in here and there is the role of OH minus. Here and there is a role of OH minus, where OH minus represents the base. Okay, the electrolyte. Here and there is, right. So in this reaction is there. In this reaction is also there. Like that, it represents the electrolytic solution, which is the base. Okay, so coming to corrosion, with this we are going to end this total chapter itself. Well, corrosion, we are going to also discuss the prevention methods, sacrificial corrosion, all these, and then we are going to end this total chapter. Okay, really believe me, this is a very easy, peasy lemon squeezy topic. Same anode cathode in the total net reaction. Okay, so what is going to happen in anode 2Fe is there. Okay, 2Fe is there, that will be converted into Fe2 plus. Okay, Fe2 plus, then plus 4. Okay, 2Fe2 plus 4E minus. Okay, plus 4E minus. Here oxygen. Okay, O2 plus 4H plus. Okay, plus 4 electrons will be giving us 2H2O. Okay, then the total reaction is going to be, it can be cancelled, right? What can be cancelled? 4 electrons. Then yeah, that's something that we can cancel. So 2Fe plus O2 plus 4H plus will be giving us 2Fe2 plus 2H2O. Okay, plus 2H2O. And here the E0 cell is going to be 1.67, and then the E0 cell of the fuel cell, the fuel cell, one important concept I forgot to say, that coming to this fuel cell, any cell, okay, any galvanic cell that can convert this combustion energy into electrical energy, then that is known as fuel cells. Those cells are known as fuel cells. Okay, so these cells are known as fuel cells. Yeah, so this is where the total net reaction is. There is this anodic side, I know. See, here there's 2Fe2 plus is there, right? So 2Fe2 plus is there now, and also plus 2H2O is there, right? So this will be further oxidized. In order to give us 2Fe3 plus H2O will be there, and oxidized in sense also oxygen will be added, also O2 will be added. Then what it will be giving us? It will be giving us Fe2O3.XH2O. It depends upon the number of H2O molecules that is there in the reaction. Okay, so Fe2O3.XH2O. Yeah. So what are the prevention methods actually? I have tried this also. Yeah. The prevention methods are painting, okay, so after painting, what is there? Then also grease. Okay, you have to apply grease, or also biphenol is a method where you can actually coat the total metal surface itself, or also you can apply different chemicals, or also inert metals can be taken. Okay, inert metals in sense Sn, then zinc. Okay, these two are those examples. Other than this, what are the examples? Okay, other than this, only one, that is sacrificial. That means, see, there is this metal surface, then along with this metal surface, if you have input another metal surface, then instead of this metal surface going corrosion, this metal surface will be undergoing corrosion. That is what it is. Okay, so for this, what they will be using is, they will be using magnesium. Magnesium and then zinc. These two can be used. Okay, so here this zinc will be inert, here this zinc will be very corrosive, and also different terms are there for this corrosion. An example for